Hello, this is Paul Rao with Technically Speaking here at Source Allies, and this is a really quick just update on something that applies to a lot of us that do development in the cloud, and that is TypeScript support on AWS. So recently Node released version 22, and version 22 has a experimental strip types flag. What this allows Node to do is strip TypeScript type annotations out of source code so you can just run a TypeScript file natively. Now, it doesn't check those types. It's not going to make sure those types are valid. It's just going to skip them. So you still need to TypeScript compile to do actual type checking. But what it does allow us to do is ship the same files to Node.js as we are running. And in most real-world applications, this has traditionally been a pain because you might have, say, a TypeScript file next to a JSON file or a YAML config file or an image or something else. You TypeScript compile everything to some output directory, and then you got to copy over all those other non-code files, and then your directory structure changes. Sometimes things work when you're running in development, but they don't work when you're actually deployed. It's a pain. You got TypeScript files being, generating JavaScript files and getting checked into source control by accident. All sorts of mess. So this is great. So in order to support this, all we have to do is pass this -- experimental strip types flag or set an environment variable to turn this on. So if we want to do a quick little example of this, if I just run over into my VS Code here, I can create a TypeScript file. I'll just call this hello.ts. And in here, I can do, console.out. Log. Hello world. Now, this is just regular JavaScript code, but it's TypeScript. So if I put my experimental strip types in here, I can run node experimental strip types and then my type file. And you'll see here that I do get a warning. Just because it's experimental. This will go away in a future version of Node when it comes out of the flag. But you can see it prints hello world here. Now, to prove that this actually is still, is TypeScript, I can put a type annotation here. For example, type, my type, message, string. So I run this, still says hello world. But if I don't run this experimental strip types, it's going to error out. It's going to say, hey, this unknown file extension, I don't know what you're doing. So, okay, great. That's cool. Let's talk about another feature of Node. So Node also added a test runner. So there's a bunch of testing libraries. There's Jest and Mocha, Jasmine. My current favorite is vtest. But they do require you adding another library to run your tests. Now, if you combine these two things together, what that allows us to do is actually run tests in Node natively. So, and it's got some really nice stuff in here. This is the docs for it. You can see we've got mocking support. We've got snapshotting support even. We've got timer support. And then some contexts. And the way that looks is it looks like this. So I went ahead and I wrote a quick little test here. And this test file, you just do, test, or you can do describe in it, just like with Jasmine or Jest. Put your test in there, and you just do assert dot equal, assert dot whatever, and there's your assertion libraries. And we're importing these from node:assert and node:test. And in order to run those, all I have to do is run, again, I'm going to run node experimental strip types, and then just do -- test, and then I can just do source/****.spec.ts, so just a glob pattern. And you'll see it really quickly ran this test. Now, this is fast. It's super fast, and that's because it's not picking up these test files and having to transpile them through a TypeScript thing, then hand them over to Node and stick itself in the Node loader to intercept everything. It's just running them natively because it's the strip type support can just skip all these TypeScript types. So we combine these two things together, and we get some really good support for TypeScript in Node without having a bunch of extra complexity in our project. So let's go through a little bit more of a real-world use case. So I've got this project that I've been demoing here is actually a Lambda project. So in order to put together this in AWS Lambda, I have a template file here. And you'll see that this template file really doesn't look any different. Let me pull it up here. Doesn't look any different than any other template for Lambda, except I did that at this environment variable. So I just said node options is -- experimental strip types. This is the line that gets us that experimental strip type support, because Lambda now supports node 22. You have to be on 22 or better. So that's the most recent release of Lambda's runtime. The other thing that kind of makes this work is that this handler here can't actually be a TypeScript file. I know, it's weird, but no, the AWS Lambda runtime expects the handler to be index.js and that to export hello world handler. So to get around that, it's actually pretty simple. We're just going to create a JavaScript file and just re-export. We'll just re-export all of our entry points. Not the end of the world. This file's really not going to change. It's going to have one row in here per Lambda in your project. Not a big deal. And then here's the actual Lambda. So this is a regular TypeScript file. Again, this is run verbatim on AWS. You can see that I have these really handy type declarations here for my request, the response from this thing. I even defined a type for my response payload. I'm just returning a hello world message here, so it's contrived example. But I do have to make sure I do import type. Remember, we're stripping types. So if I just were to do import here, then the node runtime would try to actually import this module, and it would say I can't import these two things from here because they're not really in here as like actual runtime concepts. They're only in there as type declarations. So you need import type, not just import. I think this is not a big ask. It also makes it clear in your import statements why you're importing something. Are you just importing a type declaration? Are you importing actual functions and classes and things? The other limitation, and these are all listed out on the type stripping support on the project here, but we can't do things like enums, namespaces, or the inline constructor syntactic sugar. And that's because, again, we're stripping types. We are not transpiling. So if you were to just go and do a find and replace on all the TypeScript stuff and just replace it with white space, that's what you end up with. So anything where TypeScript is actually creating new code that actually runs, or transforming code from one thing into something different that runs, like an enum or like a namespace or like a constructor property injection, this isn't going to work. Now, luckily, those features are not like super common. The enum one is a little bit common, but it's easy enough to just create an object with your values in it, or a union instead. So I do think it's pretty powerful. And again, since we're running our test here with the same exact command line flags as our actual Lambdas run with, if we were to accidentally use one of those things, the test would immediately fail because it would be valid JavaScript. So it's easy to identify. So if we combine those things together with this argument right here and that little trick around this, we now get a Lambda that we can deploy natively. So if I run AWS or SAM deploy, I've already deployed this once, so this will be no change, but it's going to go ahead and push that template and then deploy this JavaScript file and then this TypeScript file without building anything. And one of the great things about this is we don't need source maps. So because we're actually running the real code, if we see a stack trace that says something happened on line 5, it's actually line 5 in our file. So if I grab this Lambda URL here and just curl this Lambda, you can see I get hello world back. So those are the pieces. If you want to run Lambdas on AWS using TypeScript natively without a build process, without a lib directory, an out directory, and changing your upload process, and if you want to run that same TypeScript in the new Node.js test runner, here are the moving pieces that you need to do for that. Remember, you need to put it past experimental strip types until node 24. So for node 22, the current LTS version of Node, you do need to tell it that you want to opt into strip types. Remember that your handler right now still has to be a JavaScript file. So you're going to have to wrap your program in something that just re-exports from TypeScript. Remember that. Remember, you cannot use namespaces or enums or anything else that requires transpilation. So you're not dealing with all of TypeScript. You are dealing with a subset of TypeScript. And then finally, in your TS config, I recommend putting no emit true in here and allow importing TS extensions so that you can still do something like npm run type check and have it actually do a TSC on everything to make sure that all of your code is still valid and your types are valid, because that's kind of the whole point. So that's it in summary. This has been Paul Rao with Technically Speaking here at Source Allies. If you have comments about this or any of our other videos, feel free to comment and send us a message, and we will talk to you again.